Kia ora koutou, Reese from QuickSense here, and today we're looking at circle geometry and tangents specifically. Now this question is asking us to figure out the relationship between x and y. And x and y, two different angles, so what's the relationship here? Well, the other information it gives us is that these lines here, AB and CB, are tangents. So what's a tangent? Well, it might be easier if I start off with a circle to begin with. Now this circle's got a center, and if I take a straight line out from the center, like a radius, it's going to meet at a point, and the tangent is the 90 degree, right? It's the line which meets the side of this circle at 90 degrees. So I get the radius becomes a perpendicular line to the tangent. So how can I use this information? I'm just going to move my diagram over here. How can I use this information to help me out? Well, it tells me that this angle here is a right angle, this angle is a right angle, and because the shape ABCO is a quadrilateral, the interior angles add to 360 degrees. So we got 90, right, which is just in here. 90 plus, well, we've got another 90 down the bottom, right, at the tangent, plus x plus y equals 360. So 180 plus x and y equals 360. 360 take away 180, well, half of 360, right? 180. So what does this mean? Well, the relationship between x and y is that they are supplementary angles. X and y add to 180. In this next question, we're given once more a few lines of information, and we're going to have to work backwards from the information we're given to what we're expected to find out. In this instance, what they're looking for is the length of AB, so that's this line here. So from where the diameter, right, and meets at this tangent here, moves out to B. So immediately, what I want to do is start writing down some information I know. And I know because this is at a tangent, lines AB and CB are tangents, OAB is a right angle. And there are a couple of things that I can use to help there, right? I know with my right angles, this line squared plus this line squared is equal to this line squared. This is my Pythagorean theorem. So AO squared plus AB squared is equal to OB. And you'll see here, this is the side I want, AB. So is there anything else that I can use here? Well, I can use the fact that this is the radius, right? This here's the radius. So let's just be clear about that from the beginning. Right, I'm going to replace this with the radius. And what else do I know? Well, I know that the line EB, so EB is this little part in here, I know that that is 4 centimeters. I also know, right, it's 4 centimeters plus the radius for OB. So OB squared, that's the radius plus 4 squared. Now, r plus 4 squared, well, let's expand that quadratic. So that's the same as, which is the same as And if you're not sure how to do that, look up quadratic factorization. For now though, what's important is that we resolve this as much as we can. So I'm going to move r squared on the left-hand side to the other side by minusing it, and that leaves us with this equation here. The only thing I need to determine what AB is this figure here. Well, we can simplify this even more actually. So once I know the radius, I'll know what AB is. Okay, so let's use some more information. The area of the triangle DOC is 9 times the square root of 3. Okay, so the area, I'm just going to write that here, equals, and the area also equals half base times height. Now, unfortunately, I don't know what the height is yet, but I can see that we've got a couple more radius, or radii, coming off this shape. But what may not be obvious is that because it's 60 degrees, these angles in here also have to be 60 degrees. If two sides are the same, then these are the same. So 60 plus 2 times something is equal to 180. 2 times something is equal to 120. So that's got to be 60. If two sides are the same, and in this instance, all three angles are the same, then that tells us that we're dealing with an equilateral triangle. So actually I know my base now as well. Right, so my base is the same size. So I know the base is equal to the radius. So we can even start to get a better idea of this area equation. We're just going to keep a track of it. So half of the base times the height. Now how do I figure out the height? Well, one thing I'm going to do is think about it in the same way that I tried to find AB to begin with. I'm not going to think of this as an equilateral triangle. I'm going to think of this as two right angle triangles. Right, so this base here is half of the radius. I've got my height and the radius. So a squared plus b squared equals c squared. Right, and in this instance, I'm looking for b. That's what I want. So if a squared, or let's get b by itself to begin with, so b squared is equal to c squared, take away a squared. Now let's start substituting in the figures. The height squared is equal to c, which is r squared, minus a, which is half of r squared. So r squared equals quarter r squared, right? So what's this? Well, this is going to be 1 whole, take away 1 quarter, 3 quarters squared. And then if I square root the whole thing, I get 3r over 2. So I have a value for h. And I can put this back here. So I've got the radius, and I've got the height, and we're almost at the end of this question. So the area, which I also know, is 9 times the square root of 3, which is equal to, we didn't resolve this yet, which is equal to the radius, or half of the radius, and the height, which is square root of 3 over 2r, which becomes, well, half times this is, we get the r squareds over here, half of that over 4, Now I'm going to times both sides by 4. So 9 times 4, 36. Cancels out on that side. I'm going to multiply or divide both sides by the square root of 3. So 36 equals r squared, square root both sides. So r equals 6. And in this instance, because it's a real value, it's not going to be a negative number. It's a measurement. We can't have negative values there. Now, if r is 6, right, we can finally come back to our initial equation. AB is equal to the square root of 8 times 6 plus 16, which the square root of, you can do this for yourself, 64. AB is equal to, after all that work, 8 centimeters.